We're going to continue with the next 5 questions from the practice test. This question says solve -4 is less than 4x minus 6 is less than or equal to 2. I tend to call this a 3-part inequality, but it's actually a compound inequality. And when we solve an inequality like this, our goal is to get the variable by itself in the middle. And then we'll know what values that variable is between. So to get that variable by itself in the middle, we'll need to add 6. And typically with an equation, whatever you do to one side of the equation, we want to do the same thing to the other side. But since this has 3 parts, we need to do the same thing to all 3 parts. I'm also going to add 6 on this right-hand side and add 6 on the left-hand side. We're going to simplify each side. -4 plus 6 is 2. That's less than 4x. -6 and +6 zero out. And that's less than or equal to 8. We've got 4x, which is 4 times x. To cancel the 4 out, we'll divide by 4. That's the opposite of multiplication. And we're going to do the same thing on all 3 parts so that our inequality stays balanced. The left-hand side is 2 over 4. That reduces to 1/2. That is less than x. 4x over x is x. Excuse me, I misspoke there. 4x over 4 is x. And that's less than or equal to 2. So we've solved the inequality, and we have 1/2 less than x is less than or equal to 2. Or you can think of this as x is between 1/2 and 2. Let's see this on a number line. So on the real number line, we would mark 1/2 and we would mark 2. 1/2 is marked with an open circle, which is not included in the solution set. 2 is marked with a closed circle, that is included in the solution set. And x can be any value in between. So x is in between 1/2 and 2, including 2. Here we have another 3-part inequality or compound inequality. 10 is less than 6 times x minus 13 is less than -13. There's some extra instructions here. To type your solution, DNE stands for does not exist if there is no solution. So let's try to solve this. We have 10 is less than 6 times x minus 13 is less than -13. Now to solve this inequality, I would distribute the 6, and that would give 6x minus 78 is less than -13. I would add 78 onto each part. Need to do the same thing on all 3 parts so that the inequality stays balanced. That gives 88 is less than 6x is less than 65. Excuse me, yeah, 65. Then I'll divide by 6 on each part. We'll reduce, and 2 goes into 88 44 times. 2 goes into 6 3 times. 6x over 6 is x. 65 over 6 does not reduce. So we'll leave that. And the result that we got here can be a little bit confusing. Let's divide these numbers in our calculator so they feel more real to us. 44 over 3, 14.6 repeating, and 65 over 6 is 10.83 repeating. Now the reason why I mentioned that this is hard to notice is you really have to understand what these compound inequalities mean, in that this is actually two different statements that they've combined into one. That's why they call it compound. We're compounding these two together. So one statement is if we ignored the left-hand side of this inequality and only read what we see right here. And that inequality says that x is less than 10.83 repeating. So that portion of the inequality, we mark a 10.83 repeating with an open circle and shade to the left, would be these values here. The other inequality is if we ignore this part of it and only focus on this, it says 14.6 repeating is less than x. Now that's kind of hard to read, so I'm going to reverse it. And when you reverse it, you have to reverse the inequality symbol. And that says that x is greater than 14.6 repeating. So that is over here referring to the numbers that are greater than 14.6. And with this compound statement, it's an AND statement, so it needs to have both qualities. It needs to follow the rule of this one, in that the number needs to be less than 10.8, and it needs to follow this rule as well, and this rule tells us that it needs to be more than 14.6. And so as you can see, there are no real numbers that are less than 10 and also greater than 14. And so this inequality is not true. Now, if we look back to the very beginning of the problem here, you can kind of get a sense that it's not true from the beginning. You have this chain of less than symbols. Here should be the lowest number. We have 10. Here should be the highest number. We have negative 13. 10 is not less than negative 13, and so we get something that starts off wrong from the beginning. So this inequality has no solution, and we would type D and E. We have an absolute value equation on this one. We want to solve the equation absolute value of 4x plus 2 equals 12. Now with absolute value equations, you have to consider two possibilities. In this example, the absolute value equals 12, so we have to consider that the absolute value of 12 is 12, and the absolute value of negative 12 is 12. So we have two possibilities for what's inside that absolute value, and that's how we make our two cases. So our first equation is 4x plus 2 equals 12. And then we have 4x plus 2 equals negative 12. We're going to solve each of them to get all of the solutions to this equation. So solve for x by subtracting 2 on both sides. That gives 4x equals 10. Divide by 4, and x equals 5 halves after we reduce that fraction. We'll solve for x in the other equation. Subtract 2 on both sides, that's 4x equals negative 14. Divide by 4, and x equals negative 7 over 2. So we have solutions to this equation of 5 halves and negative 7 over 2. Here we have the absolute value equation. Absolute value of 5x minus 3 minus 5 equals 12. Well, we will have to consider having two cases for this example, but before we consider the cases, we need to isolate the absolute value on one side of the equation. We're going to add 5 to both sides, giving us absolute value of 5x minus 3 equals 17. Once we isolate that absolute value, now we can see the two cases. Absolute value of 17 equals 17. Absolute value of negative 17 is 17. So let's write those two cases. 5x minus 3 equals 17, or 5x minus 3 equals negative 17. We're going to solve for x on each equation by adding 3 to both sides. That gives 5x equals 20. Divide by 5 and we get x equals 4. We're going to add 3. We have 5x equals negative 14. We'll divide by 5 to get x equals negative 14 fifths. So our equation has two solutions, and just remember the key here is that you need to isolate the absolute value first. And once you isolate the absolute value, you have two possibilities for that inside of the absolute value. It can be positive of the number you have or negative of the number you have. On this example, we want to solve the system of equations by graphing. We have this system of equations which has the first equation being y equals negative 2x minus 1, and the second equation is x plus 2y equals 4. Now to solve by graphing, we're going to graph each one of these lines on the same picture and look for the intersection point. The solution will make each equation true, and the intersection point is a point that's on both lines. The first equation, y equals negative 2x minus 1, is written in slope-intercept form, y equals mx plus b. So I know the slope is negative 2, that's negative 2 over 1, which we'll use as our rise over run. And we have b being negative 1, that's our y-intercept. So we can graph that first equation by plotting the y-intercept at negative 1, and then using the slope to get to the next point. So I'm going to rise negative 2, go down 2, and then to the right 1. So we have a second point on the line. So we went down 2 and right 1 for that slope of negative 2. So we connect those 2 points to get a straight line. The second equation is x plus 2y equals 4. That's not in slope-intercept form, so I'll use a different method to graph it. I'm going to find the x and y intercepts. To find the x-intercept, I let y equal 0. I'll substitute in that 0 and we get x plus 2 times 0 equals 4. X equals 4. For the y-intercept, I let x equal 0. I get 0 plus 2y equals 4. 2y equals 4, divide by 2, and y equals 2. So I have a y-intercept at 2. An x-intercept at 4, and a y-intercept at 2. And I'll connect those points with a straight line. And like I said before, I'm looking for the intersection points. You can see that I've drawn these lines by hand, so it's a little bit hard to identify the intersection point. If I'm a little bit more careful about my graphing here, up 2 over 1 would be here, up 2 over 1 would be here. Okay, so if my line wasn't quite as sloppy, my line would be like this, and I could see that intersection point would be right here. and that's the ordered pair -2, 3. So I think the solution to this system is -2, 3, but I don't have to just guess. I can verify, and I do that by substituting that ordered pair into each equation. So if I substitute that ordered pair into y equals -2x minus 1, I would get 3 equals -2 times -2 minus 1. -2 times -2 is 4, minus 1 is 3. So that is a solution to the first equation. And let's check the other one. X plus 2y equals 4. That's -2 plus 2 times 3 equals 4. -2 plus 6 equals 4. That's also true. So we have the solution to this system being -2, 3. Thank you for checking out my videos. Have a great day.